Antares is a red giant which is at the sky at the constellation Scorpius. And that Antares is a red giant which has a diameter, so a size basically, of 250 times the one of the Sun. And the name means rival of Mars because it has a red tint like the planet Mars. That is according to the Reader's Digest Library of Modern Knowledge, Book 1, Part 1, Structure of the Universe, written by Ian Ridcliffe and John R. Shakespeare on the page 48. If you turn this video off at one point, then please tell me what the reason was so that I can improve. Otherwise, hi, welcome. I'm trying to learn space science today, Antares, and after that, Aperture synthesis. And after we've done that, we're going to do body center training. And if you participate in the body center training, then it's that you're on this. Antares, it's just dictionary entries, a gigantic red star over 250 times the diameter of the Sun. We're doing right now helioscience, and there's a question: why is in a red dwarf, all the hydrogen from everywhere churned through it? And that's basically said in a bigger star or in a red giant, where the hydrogen at the outside is never used up in the center. The hydrogen in the center is pressed together, two hydrogen atoms, and forming the helium. And that makes that thing burn, or nuclear fusion, something like that. But the point is, the hydrogen in the outside in a bigger red giant is never brought into the middle and used. So that such a red giant, or also a normal big star, never uses all its hydrogen. It just stays at the outside. A red dwarf, where all the hydrogen is at one point brought into the middle and all is used up. So it's not only burning at a lower rate, because the pressure is slower and that fusion of two hydrogen into one helium is slower because it's smaller, the gravity is smaller, but it's also that it's using up all its hydrogen. So that is why red dwarfs are burning way, way longer. Red giants quite shorter. What if and we just don't, and the question is basically why? Why is the hydrogen used? And I was just thinking, has it something to do with the size? That it is just too big the size, that it can be brought the hydrogen from the outside to the inside. Whatever. Antares is such a red giant, and it is a very big one. 250 times more diameter, 250 times bigger than the Sun. And it is in the constellation of Scorpius. Its name, meaning rival of Mars, derives from its red tint, which resembles that of Mars. Okay, Antares is a red giant. It is a... And why were the red giants? I forgot that. They're burning very strongly, but why were no red giants? Because it's happening so fast, was that the point? But why is it red dwarf and red giant? Is it red dwarfs because they are glowing basically, and red giant because they're burning so strongly? What makes it red? Whatever. Antares is a red giant. It is 250 times larger than the Sun. It is in the constellation of Scorpius, and the name means a rival of Mars, because it has a red tint which is a bit like the planet Mars. I still don't get it. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune would be 8. Okay, I'm going to start the second camera. Antares is a red giant which is at the sky at the constellation Scorpius. And that Antares is a red giant which has a diameter, so a size basically, of 250 times the one of the Sun. And the name means rival of Mars because it has a red tint like the planet Mars. That is according to the Reader's Digest Library of Modern Knowledge, Book 1, Part 1, Structure of the Universe, written by Ian Ridcliffe and John R. Shakespeare on the page 48. Where's the camera? And now we're having the other thing. Aperture synthesis. Aperture synthesis is a technique which has greatly extended the range of radio telescopes and which won for its inventor, Professor Sir Martin Ryle, in 1974, the 1974 Nobel Prize in Physics. Okay, it is a technique used in radio telescopes, and the one who has developed it or invented it has the name Sir Martin Ryle, and he won for that in 1974 the Nobel Prize in Physics. Aperture synthesis, so some type of telescope with which can be better viewed with it. Let's see it on. It uses a number of interconnected small radio dishes to build up a view of the sky that could only otherwise be seen by a vast single dish, which would be too difficult and costly to build. I don't know what a dish is. Not in space science. No entry. Dish. Radio dish, let's look at that. No. Redstone rocket. The dishes are connected in pairs to track a source of the radio waves across the sky as the Earth spins. After one series of observations, the dishes are paired with different spacings and the observations repeated next day. The different readings are stored and collated by computer. The world's largest aperture synthesis telescope, 5 kilometers long, is at Cambridge, where the technique was developed, although a bigger instrument still, called the Very Large Array, is being built in the United States of America. I don't understand. I don't know what a dish is. We can start with that. But what we're getting a lot of it. The aperture synthesis. There are different types of measurements, some type of antennas, dishes, whatever. They're sending out a signal. The next day they're doing that again, and the dishes are connected in pairs to track a source of radio waves across the sky as the Earth spins. After one series of observation, the dishes are paired with different spacings, and the observations are repeated next day. The different readings are stored and collated by computer. I don't get it. What is it that it pairs? That just seems like a system how to work, but there has to be something more to it. Okay, we just don't understand it. We don't know what dishes are or how it all looks, but we can still remember maybe aperture synthesis. Sir Martin Ryle won the Physics Nobel Prize in '74 for it. It extends the range with satellites work. They are up to 5 kilometers long, the one in Cambridge. There's another one, Very Large Array and Building in the United States of America. Then this book was written in the 1970s. And it somehow makes radio waves into the sky, and the next day again, there are always two of them, and they have an extended range. Whatever that now exactly means. That means, that was the space science part. If you were here for space science, you can go directly to the next part of space science. Who knows, maybe you're going to find out what now aperture synthesis is, and how it works. But if you stay here and participate in the body center training, then it's at your own risk. We're having the legs standing hip width apart, we're going down into the knees, flexing the leg muscles, pressing them together. Now straight one leg. Press together and flex all the time. Bend the leg again. Our legs straighten and bending. And up. A bit wider apart. Down into the knees, flex the legs and press them together. Now go over to one side, split the legs straight, press together and flex all the time. And back into the middle and over to the other side. Press together and flex all the time. Back into the middle, up. A bit closer together, press to the outside. And now, one leg up, right angle of the leg, flex foot, Even the line hips tall up with the back and press from the top against the knee. And press from the side. And press up and to the side. And press from the outside and up slowly. And close again. Other leg up and press on top. From the side. And press up and to the side. And press on the outside. Up slowly. Close again. And now the 3 exercises on your own. First the side plank. Just on the elbow first. Then one leg up. And now on the long arm. If you like, you can one leg up, one arm out, one leg up, and put the elbow to the knee. And over to the other side. First on the elbow. Arm out, leg up, and pull knee to elbow. It was not like long. It's a big hand. And again up. One heel onto the ground and pull the heel in. Move the leg from left to right. Other heel onto the ground, pull the toes in, and move the leg. And one leg up. Pull the leg up, point with the toes down. Relax the leg. Other leg. Take the leg at the ankle. Make a straight back. Point with the knee down to the ground. Other one. Straight back, knee down to the ground. Legs wide apart, breathing around. Breathing out. In and up. And out. Breathe in and close the legs. And breathe again out. That was not the special part, that was the stretching. No, the body center training. I think I very much in the next time.